Hello, dear friends. I hope you're all healthy and doing well. Uh, it is nice to talk to you again. I hope you will also meet very soon. As you know, because of the situation that we are in, we are supposed to record or meet online to have our lectures done. I've chosen to record some videos for you, although it is a little bit hard to understand mathematics like that. But I hope you will soon meet again and do what we are supposed to do in the class. And of course, I will be available for you online or offline, sending emails. I will be in touch with you and help you as much as I can. As you know, we have finished the first two chapters, and we've done also some of the sections in chapter 3. But I will start with chapter 3, section 1. So in chapter 3, we have got what? We have got differentiation. The first section that we have got, 3.1, is giving a general idea about differentiation. What is a differentiation? What are we talking about when we are saying differentiation? In general, the first notion that we have got is slope. What is a slope? We already know what is a slope when we are talking about linear functions. What are linear functions? Of course, those are the functions with the power of x equal to 1. For example, it is in general written as f of x is equal to mx plus b. When we were talking about slope in linear functions, we were considering that m that was multiplied to the x. So we were considering this one was the slope of the function, of the linear function that we have got, and that b was the y-intercept of the function. Y-intercept of the function. But when we are coming to the nonlinear functions, if it is a quadratic function, if we've got polynomials in general, we've got nonlinear functions like sine and trigonometric functions like sine, cosine, tan, cotan, and the others. We cannot find the slope of those functions in general directly. So what do we have? We have got something that's called differentiation. I've also talked about, when we were talking about differentiation and slope of a nonlinear function, I also explained the second line and tangent line. What was second line and tangent line? We said if you have got a nonlinear curve, if you have got a curve or in general, if we have got a line that's passing through the 2 points, let that one be x1, y1, and that one x2, y2, that one is called a second line. And if you have got a curve and you have got a line that is touching the curve at only one point, x and y, let's say x naught and y naught, that line is called a tangent line. In general, when we are talking about slope, it is rate of change. So in general, slope is what? Slope is rate of change. What is the relation between the rate of change and the second line tangent line that I talked about? When we are saying rate of change, slope is rate of change, we mean that any change occurring depending on something else. For example, if you have got the distance from x naught to x1, if you are moving an object from that point into that point depending on time, that's called what? Depending on time. That's called rate of change. We are changing from one position, we are going from one position to another depending on time, so that is a rate of change. If that is called s of t, the distance between the point x naught and x1, when we are saying find the rate of change of this one, well, what will it change to? It will change to velocity. So rate of change, velocity is equal to what? Is equal to the change in displacement or distance displacement. Okay, that is physically, of course. And when we are coming to a general notion, talking about slope and rate of change, we can say that when we have got a second line that's passing through two points, x1, y1, and x2, y2, if you want to find the slope of that function, okay, if you want to find the slope of that function at that given point, okay, p naught, what shall we do? We are grabbing that point, okay, down to here. We are grabbing that point and coinciding it on that point p naught. When we are doing that, what will happen to the curve and the line that we have got? And of course, this line comes to here. When we are grabbing it down, that line is coming here. It's coming here, here. At last, how will it reach point P naught? It will be a straight line passing or touching the curve of f of x at x1, y1, and that second line will change to a tangent line. Okay, it was required from us to find the slope of that function at that given point p naught. When we are grabbing that line, when we are changing the second line to a tangent line, and when we are finding the slope of the tangent line, it will be the slope of the function f of x at p naught. So what did we do? What did we talk about? We talk about slope. Okay, what is a slope? Slope is a rate of change. What is the relation between rate of change and that second line and tangent line? The relation is that we are changing when it is required from us to find the slope of that function. At a given point, we are changing the second line into a tangent line. Finding the slope of that tangent line will equal to the slope of the function f of x at point p naught. That is the general idea of a slope of a function. And of course, it is the same thing if I say find the derivative of the function, okay, f of x, find the derivative of f of x at x naught. It is the same thing as if we say find the slope of that function at that point, and it is the same thing as if we say find the rate of change of that function. So we have got three notions. They are equivalent to each other. Either we are saying find the derivative of the function at that point, or the slope of that function at that given point, or the rate of change of that function. These three are all the same. That is all about section 1, the general idea of a derivative and how we find the slope of a function at a given point.